Alright, welcome back to another video on Node.js, specifically on GraphQL module. Let me over here. Alright. So once I know what GraphQL is, which is a new query language, a new way of building front-end and back-end applications, that the beauty of this is that it allows us to see how different pieces of data in our server relate each other. So we all start by describing is the data using schemas, and if you want to ask for the data, you use queries. So this is much like selecting property in an object. That the great thing of this is since the query really match closely what the resulting object will get, we can predict what our query will return, including is a property name, regardless how the data is stored, whether it's a relational, key value, document base, graph, or white column. At least the top 5 families database in the industry. So this is something that it was created by Facebook in 2012, and unlike RESTful architecture, where you query when you make a request to get the data, and especially if you want to combine data in the browser, you have to make individual requests to query multiple collection of values and then compose that to show relevant information to the user. This is something that GraphQL solves, and it is known as the underfetching and overfetching problems. So underfetching is that we lose additional extra round trip making requests, querying multiple collection of value, thus increasing the page load time. And the overfetching is that the server sends unnecessary additional data that we need to filter out in the client. So now that we know what are the issues that GraphQL solve and how we do that by having one single entry point, so I look at how can I create my own queries by looking at tools like GraphQL, this browser building tool for testing GraphQL queries. See how can I create a query, what are the things that are doing behind the scenes, such as fetching data. This is the default behavior. And look at not only the specification like this, but also is front-end tools that allow you to create these GraphQL client-side applications with React framework, such as Relay, which has I think it's Relay framework, such as Relay, right? And more high-end products such as Apollo GraphQL, right? So before diving into this, I look at first what are the main advantage and disadvantage of using GraphQL. First, because it provides schemas and types and solve issues such as underfetching and overfetching and speed up the development process. This comes with a price because this flexibility adds complexity. So developers now need to dedicate time to learn this. So the learning curve might be quite steep. The other is a trade-off. Catching is something difficult. With RESTful, we already have proven mechanism that works out of the box, even though uh, with GraphQL we have is catching methods. For example, when we look at here, uh, catching, that's right, in the catching section. This is a more advanced topic, but this is a new way of catching uh, the GraphQL catch, the GraphQL of catching things, right? Okay, and because this is not a RESTful architecture, something that most developers are very familiar, because this is an architectural design that has been over the last 2 decades, and that is the entry point to understand how can we create our GraphQL server. So by using Node and Express as the middle and Express as our web server, and middleware such as GraphQL middleware for Express, so we can make use of that and see how GraphQL underneath the hood uses the HTTP method or HTTP protocol, and by testing our endpoints, uh, GraphQL use the HTTP post for querying data. Okay, so after that, I saw how can I create my first GraphQL server uh, using is now the GraphQL npm package, and build the schema and the type root level operation that you can write here. The the required root type field uh, is the query, where you define all of your queries. And as our applications get larger and we want to create is a more realistic project, such as e-commerce, like here, like here, such as e-commerce. Let me open here the Visual Studio Code here. Okay, right. So like e-commerce, uh, this this designing an e-commerce, and especially when you have application with some technical debt or e-commerce, it is very common to have nested objects or deep nested objects. So GraphQL is a perfect candidate for this case. Since querying data in GraphQL servers is very easy, we just ask the data that we want and hopefully get that. So our API is now organizing in types and fields rather than endpoints. So making additionally requests to query multiple collections unnecessary. So because to scale our application, uh, it is important to rely on a set of utilities such as GraphQL tools that Apollo used underneath the hood. It is important that when you took a decision to go with a particularly trend tool or package, evaluate that if you want to stick to the guidelines, all right, uh, if that guidelines are aligned to your business value, because ultimately you don't want to lose flexibility, especially to decide where you want to go, where you want to move next. Okay, so with that, So with that, once I understand what GraphQL offer, for example, is to help to organize our GraphQL server by splitting our type system, where we describe is the GraphQL capability, into multiple files, allow us to organize our server per features. Then we can pause here. So organize our server per features, and also help to organize our server when we add more complex logic to fetch our data. So I look at how can I modularize our GraphQL applications, starting with schemas, using package or using functions such as make executable function from the GraphQL package, or this GraphQL tool, this set of utility, that what it does is to, once you're using a function called load file sync, which is going to hold the server, look up for all the GraphQL extension files where you define a particular glove for that. So define is a pattern to look up under a particular folder structure and to check for all the GraphQL files, right? Once that is done, then you're gonna load that in the next executable function. And this approach is something useful, especially if you want to splitting your types or your schema into multiple files is a very good approach, as long as their types or these GraphQL files are well defined and there is no name conflict, right? I also look at the subtle details. For example, when you define is the type query, again, this is the root level operation in any GraphQL server, okay? In here and in there is where you define is per each of those GraphQL files, the query and all the possible queries you can do that. So once the function loads all of your files, it will merge those queries to generate is the entire capability that your GraphQL server expose. So great. That's actually cool. Something great, right? I also look at the type or the most common type of data that we can use in our schema. Okay. And also, if we want to modularize our application, we need to know is another component in any GraphQL server, which is resolvers. So resolvers can be answered. The question of what resolvers are can be answered of how do we make queries. So GraphQL always check for the validity of a request, of a GraphQL request, and if that is valid, and if it is valid, then it will execute that query. Meaning, during that execution, the value of the property will be determined by a function called resolver. And when you define is a query, the server calls the proper resolver for each of one of those properties, and once the query has called all the proper resolvers, it will wrap up and send back to the front. So this is the resolvers underneath the definition of the resolver and the reason of resolver. So how can we define our resolvers? Well, using is the set of utility from GraphQL tools by defining is the resolvers property, and inside of that you would set is the query, where you're going to define is the functions resolver per query, but you can quickly saw that it becomes very hard to maintain. It's a nightmare. So to make our application more modular, you can use again the npm package called GraphQL tools, and load all your resolvers. And the way you're going to define your resolvers is defining as a JavaScript file with resolvers, where inside of there you're going to export a model with the graph. You're going to export a model, an object here. Inside of that you define is the query, uh, where you're going to now define is the resolver function. And in the anatomy of this resolver function, which to illustrate here is something like, let me see if I have here. I prefer to show you from the resolvers directly, from a more elaborated resolver like this. Okay, you export that model as an object that you define is a query, and below that or inside of that you define all of your query, right? So the anatomy of the resolvers function is the parent as the first argument. This is the argument that comes from the root value. The other is the arguments that is used for parameterized query. For example, if you want to filter out data, okay, then you have is the context to share data across different resolvers. For example, sharing authenticated data across resolvers, and the info to indicate is the state of an operation. Particularly here is the state of this operation. So if you're going to use any of or a particular argument, so you use this convention, the underscore convention, and because we want to keep our resolver flat and simple as possible, here we just for demo purpose create this async operations. To see one of the benefits of using resolvers that allow us is to make API calls, good for that, and uh, because we're not going to perform any of these asynchronous operations and to keep our application scalable as much as possible, we split that into something called the data layer. A data layer where what will be doing this file is performing async API calls. Or here you define is all of your data layer functions that you're going to export this in this model, and then in the resolver, what you're gonna do in this resolver, what you're gonna do is call them, import that model here, and call them. And if that particular function needs to pass some arguments, you're going is to pass is the argument for that particular query, right? So this also leads to parameterized queries, especially uh, in our product GraphQL. This parameterized query here, we have the mean and the max here. Uh, this is something that if you want to, for example, get an individual file or get a collection of products, in our case, you pass a set of arguments for that. And again, in GraphQL, it all starts with the GraphQL extension, or by defining is the query here. Once you define the query, then you go to the resolvers, okay? And the resolver is where you're gonna call the particular data access function from the data access layer, meaning the dot model, okay? And perform the async operations. In our particular case, for demo purpose, we just only is getting the data from in memory and filter out that based on the argument that we receive, min and max data, right? Okay, so that was quite illustrated. Okay, it was very interesting, by the way. And again, believe it or not, GraphQL is not only for fetching data. So when we need to, for example, update or delete data, what is the GraphQL way of doing things? How can we make these crude operations that are fairly common operations in any backend application? Create, read, update, and delete, right? So the way of doing this, and because with APIs, getting existing data and reading it is probably the most common thing you will do, and that's why GraphQL focus on doing queries really well. But in real life applications, you need to do the other operations: create, update, and delete. So the way of doing that in GraphQL is by using something called mutation. So okay, so mutation is another operation. It's part of these two main type of operations you can do, or a GraphQL server support. You have is the query, the mutation. The query is mandatory according to the specification. The query is mandatory. If you look at this at the GraphQL specification, it tells you that this is the type system, and introspection, validation, well, you know that execution, executing request, executing type system, schemas, root operation types, right? So the root operation types, let me turn on the lights, much better. Okay. Yeah. So the root operation types in any GraphQL server is the query, which is mandatory. The root provide operation type must be provided and must be an object type. The mutation, the root operation type is optional. If it's not provided, the server does not support mutation. If it is provided, it must be an object type. And the subscription. Alright? You have these three types. Okay. Now, after I saw that, okay, um, and understand what mutations are, and under the hood, it is very similar to queries, okay? Because mutation allows you is to change the state of the data, not only to fetch data, okay? So by looking at how can we implement a mutation on the server, again, in this case, we're going to implement two mutations and see how it works. So the ability to add new product and from the ability to add a new product, and from there given give a user or give the user or give a user the ability to add a new project review. So we're going to add these two mutations, right? The ability to add a new product and give the user the ability to add new product review. In other words, or TLDR, ability to add new product and new product review, right? Okay. So in GraphQL, we always start with our schemas here. Okay. So in GraphQL, we always start with our schema right below our query. We add another root level type because it makes no sense to create a product with some nested review. Review will be later on added by the user. So first, again, in GraphQL, we always start, what the, okay. So in GraphQL, we always start with our schemas here. So whether it's a mutation, whether it's a query, mutation, or subscription. So in GraphQL, we always start with our schema. Right below our query, we add another rule level type here. In our query, this is where we add another level root type, a mutation. Again, in that particular GraphQL file extension, or in that particular functionality, we want to add that mutation. Okay, so we define here by add, okay, and defining is what are the properties we need to pass here. The ID, which is required, description as a string. There is no need to pass review, especially if you're adding a new product, okay, because that's something that users will add that, and the price as a float and is required. The return type, okay, the return type for this mutation, okay, so the return type for this mutation, this is a product, especially when you add a new product, okay. This is a common failure pattern, okay. This is a common failure pattern in APIs, serving the return type as product to indicate that data was saved. So this is a common failure pattern in APIs, setting the return type as product to indicate that data was saved. So to indicate that that data was saved, especially when you add in something, and this is a fairly common practice. This is a common fairly pattern in APIs. Okay, it's a fairly common. This is a fairly pattern. This is a common. This is a common fairly pattern. Fairly. This is a common fairly pattern in APIs, setting the return type as product to indicate. In this case, setting the return type, the product, uh, as a way to indicate that that data was saved. Okay. Next, we need to add a resolver to our mutation, and because mutations are a top level operation, just like our query, and this is something that took us quite amount of time to understand, is because why they mention that mutation are a top level operation. Exactly, because that's one of the three main root operation. Yeah. Okay, that's one of the root operations, or the root type operations: query and subscription, along with query and subscription. So okay. Mhm. Okay. So we leave our model here on that. Okay. Navigate to GraphQL here. And to implementing is the mutation.
Call add new product. And this args or an object was
So here. So next, exactly. So next, we need to add a resolver to our mutation, and because mutations are top level operations, just like our query, we add that right below under the mutation object. So we add that root level operation in our resolver here as mutation singular. The hell, okay. And inside of that object, we define is our mutation. Add new product here. So add new product here. This is a function, okay, that much like the query, it receives the parent object, the arguments, the context, and the info. Okay. In our case, we only receive is the argument, and here is where here's where I'm going to keep listening to this.
saved. There's our mutation. So what comes next? We need to add a resolver.
Mm-hmm. So what comes next? Mm. What's come next? Yeah, so what's come next?
For our new mutation. Because mutations are top-level operations, just like our queries, we add them not under the query object, but instead under the mutation object.
Mm-hmm. Under the mutation object,
which is also a map or an object.
exactly, which is also a map or an object
that takes the name of our mutation, so add new product, and sets it to some resolver function.
mm-hmm. that takes the name of our mutation and sum in a resolver function.
We'll use this anonymous function, and the arguments to our resolver are the exact same as with our queries. The first argument is this parent, which we won't use, so we're going to set that as underscore, following the same convention as before, but we will make heavy use of these args that were passed in, which contain our product data. What is the body of our resolver going to look like? We're going to make,
for example, like this. So what is the body of our resolver?
were passed in, which contain our product data. What is the body of our resolver going to look like?
What is the body resolver? What is the body resolver is going to look like?
We're going to make some function in our products model that will add a new product. And we're going to put all of the logic to create a new product and save it to our data model in this function to keep our resolvers as thin and small as possible. What is the body of our resolver going to look like? We're going to make some function in our products model.
Okay, so we're going to create. We're going to set some function in our product model, exactly in this particular case. So we're going to set some function in our product model
That will add a new product.
in product model that will add
And we're going
a new product.
to put all of the logic to create a new product and save it to our data model in this function to keep our resolvers as
And we are going to put all the
logic to create a new product and
exactly. We're going to put all the logic to create new products in our model, in our products, or in our data access layer. The product dot model.
save it to our data model in this function to keep our resolvers as
thin and clean as possible.
thin and small as
Okay, thin and small as possible.
possible. We want these resolvers to be independent of whichever model we choose to use.
Exactly, we want such model to be independent,
Thin and small as possible. We want these resolvers to be independent.
We want these resolvers. Okay, we want these resolvers, the product dot resolvers. We want these resolvers independent
Of whichever model we choose to use.
We want this resolver independent whichever model we want to use.
Whatever thin and small as possible. We want these resolvers to be independent of whichever
Exactly, we want these resolvers be independent
model we choose to use.
whichever model we choose to use, or we want to use, we choose to use.
Whatever database we're using.
Whatever database they using.
And any other implementation details.
And any other implementation detail. This is something crucial here, and I know I'm going to dedicate quite a lot of time to perhaps a couple days here to look at this in depth, because there's a lot of things going on, a lot of concept that he went through. Okay, so for example, it's like yes, okay, describing is how can we create or how can we implement our mutation by looking is at the schema for that particular feature or capability slash type, and much like the type query, here we define is this root level operation is called mutation. And in there, you define is, in our case, add new product. So we pass is the argument needed for this particular mutation and the return type as a product. And this is a fairly common practice when building, when designing APIs to indicate that that data was saved. So then what's next, or what's come next, is the creation of the mutation in our resolvers. So similar as we define as a query, right below that we define is the root level operation, the mutations, and uh, here, which all exactly, which is a mutation object, which is also a map or an object that takes the name of the mutation and a resolver function. You know, that takes the name of our mutation and a resolver function. What is the body resolver is going to look like? So we're going to set some function in our project model that will be add a new product, and we're going to put all the logic to create new products in our data access layer, the product model, to keep our resolvers independent, so to keep our resolver as things and small as possible. We want to we want this resolver be independent whichever model we choose to use, whether whatever database they using and any other implementation detail. Again, this is part of the high cohesion and low decoupling. Meaning is that the less responsibility, the less responsibility, the TLDR for high cohesion and low coupling is that the less responsibility that a model has, and the less model and the less dependency it has. So the less responsibility and uh, the less responsibility and dependency this model has, the better. The TLDR, right? The TLDR. The less responsibility that this model has, or this file has, and the less dependency it has, the better. Okay. So be independent whichever model we choose to use, whatever database they're using, and any other whatever database they're using, and any other implementation details.
All we're going to do is pass in all of our args into this function. The arguments we need are args.id, args.description,
So we are going to pass is the argument it needs. Mm-hmm. Yeah, so we're going to pass is the argument it needs. And in our particular case is this new function from the product model, add new product. So we're gonna pass is the argument, like the argument dot id, the argument dot description, the argument dot price, and along.
And args.price. This function will return back the product that was added, so we'll return.
So this function will return the product that was added, which is in our case is going to return this. Mm,
That value back as the result from our resolver. That's the GraphQL part. But how does our model implement this add new product function? Let's take a look in products.model.js, where we'll
exactly, but how this add new product implement this function.
add a function at the bottom that we'll call add new product. And this function will accept our three arguments: ID, description, and price. We'll create a new product in a constant, let's call it new product, and that's going to be an object which contains our ID, the price, the description, and
So this is the implementation details. This is the product where you define this as a map or an object. What you have is the ID, the descriptions, and the price, thanks to the auto completion feature from the EX6 that you don't need to do some things like this. ID is equal to ID or things like this. Alright, it automatically do that behind the scenes for you. Okay.
also we should set our reviews field to either null or, better yet, an empty array.
So we should set our review object to whether null or empty object
to show that this fresh product has no reviews. Now, to be consistent with our pre-populated products array here, let's add an empty reviews array for each of our test products here. So reviews is an empty array, and for blue jeans, we also have reviews being empty. Back in our model function here, we'll take this new product and push it to our products database.
Okay, back to our add new product, and here we're gonna just push is into our database, which is our product, the push the product.
Or in our case, the in-memory list of products. We'll take the products array and push the new product we just created. Our mutation returns back the product that was just created, so we'll return back this new product, which will
What we can say is this new product. New product for consistency.
come back from our model function here, back into the resolver, and finally be returned back to the client that added the product. Last but not least, we need to export our add new product function.
And then last but not least, we need to export our add new function.
Let's test our work. So we'll start up our GraphQL server. Here in Graphical, let's try adding a new product. Just like with queries, we can make multiple.
So we can use this the NVN, use the version 14, the NVN star here, or GraphQL server, navigate to that path, and oops, ask for that
Mutations.
So define here as mutation here. Come on. Define here as our mutations here. With the mutation here, query, as our add new product. Where the ID here,
All with one trip to the server.
is ID, red shoe, rating. There is no rating here.
So above our add new product review mutation, we'll add a add new product mutation, where we create a product, $70.55. Add new with an ID that's say orange jacket.
Okay, this is it exactly. Like orange jacket. Then the description.
And the description is going to match our ID. So description will be orange jacket, which is going to be a
orange jacket. Orange jacket.
bit more expensive than our shoes. So we'll say the price is $70.
Which will be a little bit more expensive than our shoes, which is $70.
And 55 cents.
Okay. 70, 55 cents.
And what we'll get back from this mutation is
the product. And what will we and what will we get back from this? And what will we get? And what will we get back from this? And what will we get? And what will we get back from this?
the ID of the product and
is the ID of the product
any reviews.
in any reviews. So we add new data. No.
Which we decided is going to be empty. We're trying to make. So at the bottom of our error, of course, let's see what comes back now. Just the which works.
Data add new project. No. ID orange jacket. Description. Review rating. Description and the price. It says add new product as no. When I look at the mutation of it here, the return is a product with a description and review. But this new file here, of course, is not pushing anything. So we're going to rerun this server again. Okay, we run this. And once we perform this, we get data, add new product. No. Perhaps we didn't add that, we didn't save that mutation properly. That's what happened. And when we run this again, we already get that as supposed to. Okay. So with that, I will see you in the next video. Take care. Bye bye.